I want to use my microscope, Mommy.
You have to see the doctor first, Lily. You broke your arm falling from the tree.
That's a nice microscope you got there, kid.
Yes, it is. It's really nice. I got it for my birthday, and it's really special because it's connected to
A CCD camera.
Yeah, how'd you know?
I have a CCD camera just like that.
You have a special microscope too?
No, not quite. I'm an astronomer, and I use a CCD camera to look at space.
You use a microscope to look at outer space.
No, not quite. I use a telescope that has a CCD camera to look into other galaxies.
Galaxies? I've only used my microscope to look at a leaf in a tree, but it didn't work out too well. I fell and I broke my arm.
Oh, that's not good.
No, but the microscope is okay. Hey, do you know how this camera works? I learned about microscopes in school, but I don't know how a CCD camera works.
As a matter of fact, I do know how it works. A scientific charge-coupled device camera, or CCD, is used in a wide range of fields, from astrophotography to microbiology. They work by changing the light energy into electrical energy. When light enters the camera as photons, these photons are converted into electrical energy at the silicon-coated surface. The silicon surface creates an interface that can clearly convert the photons into electrons with a minimum amount of background noise. The electronic signal created by the photons is proportional to the amount of light of the contacted silicon surface.
What happens to the electronic signal?
Under the silicon surface lies a grid array. Each microscopic section of this array is equivalent to 1 pixel element of the image taken by the CCD. Electrons created by the signal travel down the aluminum alloy that creates this array. The signal is collected at the border of the CCD. Once the electrical signal is compiled, it can be stored as a digital image.
So, do you control a CCD camera just like a regular camera?
In some ways, yes. A CCD camera is also prone to over and underexposure, just like a regular camera. If an image is overexposed, the lighter regions lose detail, but if it's underexposed, there's less sensitivity to the darker regions of the image. Unlike a regular camera, which captures only about 2% of gathered light, a CCD camera is responsive to about 70% of gathered light.
What do scientists do with these images?
Many things. In an exposure taken by a CCD camera, the image is only black and white. The brightness of the exposure can be analyzed specifically due to the sensitivity of each of the pixels. This brightness is used to make measurements based upon determined algorithms that are determined by the scientists that model each situation. The images can be manipulated using software on a computer to turn the black and white image into a colored image.
How clear are the pictures that the scientists use?
The transference of photons into electrons is very, very sensitive to background noise. And in order to make a clear image for the scientists to use, some CCD cameras are cooled to very low temperatures using liquid nitrogen. The images are prone to a phenomenon called dirt current, which is created by the thermal energy released from the transformation of the photons into electrons. And in order to reduce the effect of this heat on the image, the cooling is necessary.
Do all scientists use these cameras?
CCD cameras are used for collecting and analyzing data in medical fields, physics, astronomy, industrial automation, quality control, security technologies, cell phone screens, fluorescence microscopy, DNA analysis, forensic analysis, and countless other applications. CCD cameras are becoming very common. There are even CCD cameras within this hospital, such as in the X-ray machines.
Really? Hey Mom, did you hear that? The doctor's gonna take an X-ray of my arm. Are you getting an X-ray too?
Speaking of X-rays, sorry for the wait, guys. Our X-ray machine has been broken for a while now. There's a problem with the imaging device.
Is it the CCD camera?
Actually, yes, it is.
Let's go fix it.
Let's go.